Hello, everyone. Back for more. This is the would be the fourth, the scheduled fourth, but the third in a series of question and answer I'm doing on live stream on YouTube and Twitch, just to take your questions about AMSAT, satellites, engineering in general, and an opportunity to discuss in depth a lot of the things that don't get to be covered in depth at most public outings that we do. There's a lot to it. There's a lot to even if you wrote up an article every 2 months in the journal or something, it would be very difficult to keep up with it. So I'm going to pause a moment, see if anybody is going to be around to drop in. I realize it's field day, and there's probably a lot of people that are out there having more fun, but I had already scheduled this and put it out in advance, so I figured I'll go ahead and follow through with it. And anyways, it's always hotter than a pistol here in Texas. So even though it's only 92 right now, heat index is up there around 100, and that's warm enough. I've done enough field days like that. I figured that the way it was actually kind of the first Q&A that we had got led on by the idea of just talking about different topics within what we do, as opposed to specifically sitting here waiting for a question and an answer. And so I'm going to do the same thing. I'll pick a slide probably from a slideshow that I have to start in. Normally I would have access to a lot more diagrams, pictures, what have you. But my main PC, Diana is the name of the PC, it blew the water pump Sunday night. So that meant that the replacement part didn't get here till yesterday, and that didn't leave time to reinstall the water pump and the coolant and all that stuff in time for these meetings. So I decided I'll just go ahead and keep on at it using my laptop Dolores, a ThinkPad, which is a very, very good kind of laptop to have. Actually started out with what was the ThinkPad? Was the one with the butterfly keyboard. I can't remember the model number of it, but in the 90s I got one of those, and it was the best keyboard for typing that I'd had. And through a number of iterations of laptops over the years, went back to the ThinkPad in 2018 or 2019, and it was the best thing that happened, because if I taken it on the road with me, which obviously I do for work and what have you, and I'm usually finishing presentations the night before in the hotel room, so having a good keyboard is unbeatable, and it's working especially great for that here with the outboard monitor, so I can run 2 monitors. But I do have the chat down below, so to speak. I've got the laptop on my keyboard tray, so that's where the chat is showing, and then on the bigger screen, my big monitor here in the office is where I'm showing the slides or whatever, so I can pick out and talk about the various things, and then also display the screen to you. So I'm going to drop out of this big view of the slideshow. Let's see, I'll kind of pick a place to jump in. I think I would like to, not right off the bat, we'll wait till we get some more people, but this is a presentation that one of our engineers, also a AMSAT board member, Zach Metzinger, put together for our AMSAT Symposium 2023. And it's about, it's a presentation about AMSAT Golf, our Golf Satellite Series, that he made to the North Texas Microwave Society. And it's got a good tie into what we're doing with the move to the microwaves, because organizations such as NTMS, they have the interest in working with the microwaves, but also the expertise, the availability of input and ideas from their members that can help us to make the best choices for what to do with the microwave. It will be microwave, it will be five and dime, but how to implement, or especially on the ground station end of it, the building of a ground station and such. So I'll get to that then a little bit later. We've got 2 hours of this, so hour and 55 minutes more of me talking. However, if anybody wants to drop in, and anybody who is there, if you're there already, I typically can see people dropping in on the chat window here, but just to make sure, if you don't mind, turn off autosave here. I didn't notice that was on. If you don't mind, just say hi or something so that I know who's there. And if you got call sign, your call sign, let me know if you're an AMSAT member. I've had some people on the last session that came by that were that were not AMSAT members, but were very interested in what I was talking about. So I can talk in different terms, depending on your familiarity with, if I say a Gulf satellite, if you know what the heck I'm talking about or not. And even if you are a member and you don't know what the heck I'm talking about, just say so. It's the range of everything that there is to talk about engineering-wise. It's hard to know exactly where, because I'm not an expert streamer or orator, really. It's hard to know where to hit that level that's going to be something that's going to be understood by as many people as I can reach. And I see I just got about 3 joins right here. I don't know if y'all just said hello at once or whether the thing was backed up for a second. I see Paulo, PV8DX. Hello. Hola. Matthew. I haven't heard from you for a while, Matthew. Hi there. And Tim, is it Sasha Tim or VE3SVS? SVF. Sounds like your call is sort of familiar. But I'm heck with names. I'll tell you that right off the bat. If I don't meet you about 6 times, or you have a unique name, then I'm not going to get it. But I'm glad you're all here. And so, because you're all here and willing to say hi, is there anything that you want to have me touch on? I can start talking about things, but what the heck, why you're here, unless you plan on sitting here the whole 2 hours, which would be cool, but whatever. Give me an idea, and I can kind of dive into a topic that might be something that is on your mind right now about all the stuff we're doing. And if I go back to the first slide of this show here, no, that does not exactly hit it. So, but I've got presentations from previous symposium, Hamvention this year, and such like that, because my main PC being down, that's where a lot of the loose articles I had was, as far as, just a variety of pictures and slides and stuff like that. So pretty much I'm picking from these various presentations. You know what I'll do? Maybe I'll start with that one that Zach did. Zach Metziger gave this presentation to the North Texas Microwave Society back on October of last year. So it was right around symposium time as well. And it might be that date is what he picked to put on here, because he did show it at the AMSAT symposium. In any case, he's talking to the terrestrial, if you will, microwave group, North Texas Microwave Society, NTMS local group, because Zach is in the Dallas area. And it's interesting because he touches on the variety of work that we're doing with the microwave. Here's something that's of interest. I don't care. I mean, even if I've been around AMSAT for, gee whiz, 50 years? I guess so. Yeah. Anyways, so now I feel really old, but I wasn't there that way back when the first satellite was created. The group of hams that were with, I believe, Lockheed, and this is in 1961, and they made the first satellite. You can see Lance Jenner is the one holding the satellite in the picture in the upper right, and that was named Oscar 1, Oscar for Orbiting Satellite Carrying Amateur Radio. And that satellite was just an idea they had as a group of hams in the ham club of Lockheed there out somewhere in California. But they found a ride for it on one of the Athena rockets, I believe it was. Athena rocket, Aurora satellite, if I have that in the right order. And so that flew on one of the Air Force rockets in 1961. So it was about just 4 years after Sputnik that they put the first ham radio satellite up. And AMSAT itself as the corporation wasn't founded until 1969, but it was grown from the original group of members there. And the last of the big satellites that was done, in the bottom right picture, is something else. And hang on just a second, let me read this question from Sasha. Apologies for my ignorance. What type of telemetry planned for the Gulf satellites? Okay, I'll get to that in just a minute. And I'll just go ahead and drop off this and get to it after I say AO40 there, that 10,000 pound satellite. I wish, working with the CubeSats now, this is what 1 U of a CubeSat is, about 4 inches cubed, although this box is not cubed. So that's the size of the satellite there that we put stuff in for, like the Fox satellites, compare it to the 10,000. And the max weight on that was for 1 U, it was about 1.1 kilograms. So quite a difference there. To go to the question about the telemetry protocol and hardware, the specific protocol it's not proprietary, but it is what we created. Actually, it'll be using the same basic protocol as, let me get this out of my eyes, as the Fox satellites used. So it's going to be, but this is going to be a 1200 BPSK format. Will be the telemetry downlink, and now that's on the VHF UHF. Pardon me a second. On the VHF UHF, the linear transponder module. So the downlink on 70 centimeters on a separate channel from the rest of the transponder, 30 kilohertz wide. Will be 1200 BPSK, and it can be set to carry a variety of science or satellite or combination and such like that. And specifically as far as decoding it, FoxTelem, the software FoxTelem, if you're familiar with it, that was written for the Fox 1 satellites, and it has included those plus HuskySat and now main MESat that's supposed to launch in a few days. Because they're flying that linear transponder module, you'll be able to downlink and decode any of that telemetry with that same software. So the basic telemetry stream is going to be the same type of operation, at least. I'd have to refer you to Burns Fisher, WB1FJ, or others that worked on the specific software coding. In fact, Chris Thompson, he's living in Canada now. He was in the U.S. at the time that we did the original FoxTelem creation, but I can't remember where. I think he's around Montreal. And in any case, he is the key player in that FoxTelem software. So he can certainly tell you everything about it. I don't know his Canadian call sign. And as a matter of fact, since I haven't referenced him in a while, I can't remember what his US or UK call sign was. You could check AMSAT publications or even the AMSAT website. I'm sure he shows up in there because he wrote the FoxTelem software. The FoxTelem software has a reference to his personal website that is where all the information is about. It's open source on how the FoxTelem works, and that would tell you what's there as far as the error correction and stuff. I know it was a 10B2? It's way back, and I'm not a software person, so I just know a little bit about enough to be dangerous. So overseeing the entire group. The Phil Karn had helped with that originally, and that's what was put together for Fox 1, primarily out of the growth that had happened before I became VPE. So I'm not laying any blame on anybody, but I just don't know what was put into it, what the choices were. And that is what has been running on the Fox satellites. Now for the microwave, because you do mention the footprint and lots of FEC, for the 10 gigahertz downlink of the high-speed telemetry, pardon me, that specifically, again, they're going to have the answer to that question specifically. It's going to have a lot of FEC. It's also going to have a pilot for Doppler. That's the plan for the 10 gigahertz, especially in LEO, because it is going to be zinging by. We don't expect that there's going to be a lot of people doing the telemetry, but everybody trying is great. I mean, that's how it works with the experimentation and stuff as we get it tweaked up. Now, hopefully, as we get higher up in altitude, orbital altitude, and we don't have to be chasing Doppler and such like that, then things will be able to go to a higher speed downlink, literally, which is the goal. But for the demonstration, for the proof of concept written up to NASA in our CSLI, it is to have a 1 megabit high-speed telemetry downlink. And so, sorry I don't have that specific. G0KLA, Matthew reminds me, is Chris's UK call. And so you can look up, you could probably, search G0KLA. We just ate supper, I apologize. G0KLA, and I'm sure you'll find his website and everything. So you can get that from Chris Thompson. And he may have stuff about the microwave in there as well, because that is pretty well developed, the SDR, the protocol and stuff. So I think that you may be able to find more there. If you can't, you could try hitting up on the AMSAT BB as well. Or if you can't get find any leads on it, just email me. You can reach me, VPE, Vice President Engineering, at AMSAT.us. It's AMSAT.us just because it drives Matthew nuts. But seriously, it's AMSAT US because I had too much trouble with SPF, DNS, and all that kind of junk that I just got my own domain about 10 years ago when I got this job. So in any case, just email me, VPE at AMSAT.us, if you can't connect with anybody, and I'll hook you up with Burns and Ray Roberge is the SDR guru who's been working on that, as well as Chris Thompson. So there you go. I hope that answers your question. I mean, yeah, sometimes I don't have specifics. It's just a matter of trying to keep up with everything to that detail. And those guys have been doing it so long, over 10 years, for the Fox satellites, that it's just, it runs itself in a sense, right? As far as the telemetry, Fox Telem, all that kind of stuff, it's something that doesn't require a lot of attention. Even though we are going into new ground with the Gulf satellites, there are bigger things that require the attention, and that it just, like I said, it takes care of itself. So that's good. We got KH6WI. Ham Radio Ohana. Aloha. Thanks for dropping in, by the way, and reading your question way down here at the bottom. Growing concerns about the radio manufacturers not making enough full duplex radios. Yeah, we have had the 9700 and a few FM mobiles still in production, and not much else. I guess, in the big scheme of things, and I get this a little bit from talking to Yaesu reps at Hamcom here in Texas, and that was probably, that thing's been out of business for almost 5 years, I'll bet you. So could have been a decade ago, but I don't think it was that long because I was VPE at the time. In any case, in talking to them, and that was when we were just talking about FM Fox satellites, not even linear transponder and such yet. They had sort of interest, but I got the idea that, and it makes perfect sense, that, you know, for the market slice of, you know, ham radio total, there's not that many people who are into satellite, and therefore not a whole lot of bucks to be made depending on the ROI for that type of gear. Now the FT736, I had that, and I still have it. I just got the 9700 in place. That was a great radio, and it's too bad they didn't just carry on with that. But then, you know, I'm not in the business of being in a business. I've always been a worker bee, not the proprietor. So it is something that they have to sway to. Now, my opinion or thoughts about ICOM is that they're on to that, and that they are probably the best shot for having any kind of full duplex type of stuff. The 9700, I recall 2 or 3 years ago at Hamvention, and when they first had the 9700 out there on display, and I was talking to them about it, and they said it was going to, you know, had the 1.2, 2.4, and 10 gigahertz, and I suggested to them, you might want to consider adding 5 gigahertz, because this is where, or was it 10? Was it the 10 they had? I can't remember if they asked it was about the 10 or not. Might have been the other way around. I might have suggested the 10 because of QO100, because I think it had a little more weight than simply the 5 and dime idea. And so it appears that they had enough feedback about that it was a wise choice for them to go ahead and do it. So they were making a radio for, basically it's terrestrial rooted, because that's where there's probably more business for it. But there is also growing satellite business, and especially on the microwave end of things, that they did add the 5 or the 10, I forget, I'm getting old. They did add the 5 or the 10 gigahertz piece of it, and so that really starts to bring that together as a very capable radio for where we're going with the microwave, with the Gulf satellites and beyond, if you will. The 5 and dime. For Gulf, we're planning on having, on Gulf 1, which will be the first full implementation, the 5 up, 10 down, 5 and dime, 5 gigahertz, 10 gigahertz operating plan, and also 2.4, so 2.4 up, 10 gigahertz down, because of QO100 and all of the stations in on that side of the Atlantic that have their station setups for 2.4 and 10 gigahertz, helping to, you know, bring it together so it's a worldwide possibility. The ICOM 9700 helps fall in there. There have been shortcomings to it. One of them has to do with the way we commanded the Fox satellites. The 9700 would not allow that wide of a signal on FM, basically, to be able to command the satellites. So the 9700 was a flop as far as being able to command the satellites. You could not get enough deviation out of it like what we needed. And it also has impacted our operations team in FalconSat. FalconSat was the digital satellite, the digipeater, store and forward, and the 9700 wouldn't do 9600 baud, wouldn't do that, and therefore they couldn't use that radio for commanding the satellite either. So that's something that I know that there are a lot of complaints filed to ICOM about it. I don't believe that I don't know if they have any plans to do anything. It would be nice if they want to keep up with what they're doing with the radio. So beyond what's in the 9700 or existing older radios, 910, actually the ICOM 910 had the same problem for commanding the Fox satellites because it also had that lockdown on the deviation. I used my 817 when I was doing it. So for other work like Fox Plus with FM, for example, it's going to be linear transponder, 30 kilohertz, the LTM, on the first flight, but the whole idea of Fox Plus is to have more more rapid, I guess, rapid launches, so that there's more, a constant flow of satellites up there, and then also testing or carrying different types of radio. So there's a 4-channel FM board that's in development, and then of course an FM HT, because it's going to be LEO and in the Fox format, if you will. I guess, well, who was it? Kenwood. See, now I haven't operated a lot beyond what I did with my, base station stuff, 736 and 9700. So the HTs, Kenwood has one, or had one anyway, right? And other than that, I don't know about the full duplex stuff. I know my Yaesu HT did it. Or did it? Gosh, I don't know. It's been a while. How's that? I kind of ran into a wall at the end of the answer there. I think that being in touch, especially with ICOM, they seem to be responsive to. Yeah, actually, I mean, they were taking notes at that first time when I was talking to them, and they said, "Hang on, we're going to write this down." So they were at least serious about taking stuff back. And when I talked to the engineer the next year, he said that they had, gotten together a meeting, not specifically necessarily about what I said, but that was an aggregate of what was said by many people, and they actually took it to, the corporation took it to heart to look into all that stuff. So that's probably the best bet for keeping up with what's going on as far as having the full duplex capability. The 5 and dime or 2.4 and 10, those give opportunities for discrete transmitters and receivers, simply because, and the 5 and dime was chosen, those frequencies, in part due to the fact that there is a lot of stuff available at a reasonable cost for those frequencies. So while there are no plans can ever hit for a ground station on that yet, Jonathan Brandenburg, who was AVP for a while, AVPE, and had to step back for real life stuff, gets in the way of ham radio, doesn't it? And so he's wanting to get back into it, and he's going to start working on the ground station components. So he's got some ideas already about that, and there will be more coming out about that. It's not a commercially available type of thing, although he's talking about using some commercially available components for it. Not components like in the board level components, but microwave equipment that's available. And I can't remember the specifics if he mentioned any name of one, but that'll be information forthcoming pretty soon. Certainly by symposium, he's going to have something on that, I'm sure. And Pedro, hello. How are you? Glad you dropped in. I like this. There's a pretty good turnout so far for this. Some of the other ones, well, there was a number of people on, but they weren't as vocal, I guess you'd say. So not a lot of specific questions or thoughts. From AMSAT Argentina, and asking about, I don't know if y'all can see the chat because I'm going out to 3 different streaming services. We got Beam and then Twitch and then YouTube, and I see all the incoming, but I'm not sure you're all on the same platform and can see each other. Are there AMSAT NA any plans? Yeah, does AMSAT NA have any plans to design, share, or provide converters for 5 and 10 capabilities? Well, that touches, on what Jonathan Brandenburg was doing. Excuse me. Oil up them jaw joints, right? So, and that's not beer. That's a advertisement right there. Locked in beverage. It's kind of a energy drink, I guess. So Jonathan's working on, gosh, if I had my normal computer, I could show you what he's working on, but I'm doing totally by memory right now from some introductory slides he sent me. But working on the design for a 5 and dime ground station, the 5 and dime ground station, not just at Golf T, but I told him make the range of it basically for HEO, which would still then cover Golf T. the size of the satellite or size of the dish, or the antenna, whichever it is, it's going to be dish or whatever, is something you might want to have fairly easily movable for chasing Golf T or Omni. Ray Roberge, who's doing the SDR, the 10 gigahertz downlink, has said that it is not likely that Omni's going to work for that for LEO, but he may come up with some ideas. In any case, to your question specifically, it's all about designing and sharing. It's going to be an ASCENT project, and ASCENT projects are all going under the open source, open access umbrella now that we have created, so that all of that stuff, whether or not, you know, it's available to everyone in the public. It's on GitHub essentially. So you'll be able to go to GitHub and see what's going on, and it will be intended to publish the designs to be things that you can buy or build to put together a ground station for 5 and dime. Specifically, he's addressing 5 and dime because in Europe they have the 2.4 and 10 covered. And so, and I say Europe in general, but across the ocean. So the 5 and dime is what he's putting together. That was a component that we started actually about 10 years ago that was going along with the CubeQuest Challenge, Heimdallr satellite that ASCENT was involved with, and then also Phase 4B was going to do it. And but the ground station never got off the ground. Sorry, that just fell right into that. The ground station never got going primarily because of the failure of Phase 4B to be able to find a flight to get going. Now we've got energy to kick it back up because Golf is going there, and as soon as Golf T. So he will be putting out all sorts of stuff. You know, it'll be available GitHub. I'm sure, like I said, he'll be talking about it Symposium, possibly, because Symposium's not that far away, but AMSAT journal stuff depends on how fast he gets how deep. But for this year, he was planning on being able to have the first stage of it, at least in his budget request. And additionally, he makes a note of this, and that is that it will be perfectly operable in bands and such and modes and stuff like that for terrestrial. So it's not just limited to satellite use. The whole setup is 5 and 10 gigahertz, can also be used for terrestrial use. So that gives, you know, a little bit wider market for it, so to speak. Also, because it is a open source type project, then that means more feedback from that community, North Texas Microwave Society, for example, into better or alternative, you know, and methods and the design of it. So I think it's going to be a good thing overall, and it will get going quickly to be ready to at least, you know, minimum copy some of the telemetry from the Golf. By the way, just to add real quick, the Golf T Golf T I plan to be able to fly because the guys came up with the idea and the capability way back, really. It's got a 435 megahertz, 70 centimeter little antenna built into that multiband antenna that hangs off the side. And that's a pick to pick off the downlink from the VHF UHF linear transponder module. The SDR picks that up and then rebroadcasts it, if you will, on 10 gigahertz. This depending on power, but it would be lovely. I'm hoping to be able to run it in concert with the, so you got your VHF, UHF, linear transponder mode, but also that downlink's coming on 10 gigahertz. So you can do a VX mode, VHF up and X band, 10 gigahertz down. That should be available on Golf T if all holds well, but do remember that Golf T is the first iteration of testing, hence the T name, of all these new technologies that we need for building the bigger, better microwave GEO satellites and such like that. So there's no guarantee everything's going to work. Worst case failure on that, it'll be a VHF, UHF amateur satellite. So I hope that covers that good for you. And it's a good question, good timing on that, because that's exactly what's going on to design a ground station with the components and the plans or where to buy. And let's see, CQ PY2M. PY2M, I guess is your call sign. PY2RN. Hey, Ed. Okay. Ed's, why didn't I hear the beep? Ed's asking about the add-on Pluto, 70 megahertz, 6 gigahertz. Just got one. Oh, hey, that's great. And if you're interested, Ray Roberts has been working with one of those in his designs. Now, maybe you saw some of his presentations from previous symposiums. And if not, you could go back to the proceedings probably and pick up something on that. But I know that he has been working with one of those. And so just tossing that out there in case you want to, you know, connect with him maybe and get some ideas or inject some ideas or just talk about ideas or whatever's going on with him for the SDR, specifically EDIS 310 for golf T, but you know, what's going on with that. And he's also working on the design of the SDRB, which is a replacement, essentially same capability as the E310, but in a format, a footprint that'll fit into our stack on the Gulf satellites. And then also, you're asking, 10 gigahertz receive is easy with 25 megahertz PLL in INB. Not sure what that means, but with a modified temperature-controlled crystal oscillator, or, well, you're talking about, yeah, GPSDO. You're talking about the type of stuff that Ray was talking about. And with the idea of a pilot too, to be able to help you with the Doppler to tune it. He, in the iterations of components that he's talked about, one of the things that he said, if I remember accurately, because we're going back a few years, but had to do with the fact that as a reference for frequency for setting up your receiver, using the ATCS, is that it? The digital TV ATCS carriers that are pretty accurate, I guess. I looked at the ones around here, and either my SDR, which is currently a oh geez, what do you call it? Well, anyway, I've got one. AirSpy. I've got the AirSpy and then the FunCube, but they some of them weren't all that accurate, or at least they didn't agree with the one that was 7 megahertz down there, right? So, but anyway, that's something else he's looking at as well. So I think you know, if you haven't seen what he has been putting out yet, check it out, and maybe you would have something to talk to him about too. Like I said, the whole SDRB is a ASCENT project. ASCENT, making something an ASCENT project pretty much means that we don't have a specific mission targeted for it yet. But the idea is that people are working on stuff that will be for future satellites. It's something that they think of. And basically, I say, hey, yeah, that's something that we'll be able to use. And so we give some funding, and they work on that. And then I also know what mission capabilities, mission meaning launches, that we have, or what type of satellites we're going to fly on the variety of launches. So I can either tailor the mission for the new device, or give input, general input, because I don't want to be telling anybody what to build. General input for or guidance for that device, that system, whatever they're developing, in order to make it, give it the best opportunity to be on a flight. You know, in other words, you don't want to. I can't even think of an example, but you just don't want to build something that won't fit in a CubeSat or something, basically, right? So that's the kind of guidance I'm talking about. LU7ABF, Pedro, golly. Yeah, you've got the question about that gets a long contact with ARIS. Oh, hey. Good impulse 5 and diamond transponder aboard ISS would be very useful to train on QL100 users. That's a thought. That's an interesting thought. So there is in discussion, in talking with ARIS, because, you know, ARIS used to be part of AMSAT, and so Frank Bauer and I'm just like heck with names tonight. Well, anyway, we'll leave it at that for right now. talking to Frank most recently, which was actually back at last symposium specifically, because I didn't make it to Hamvention this year. The idea of using 5 and dime on Eris projects, especially the lunar stuff, is very much a thing, and 2.4, 5, and 10. So it's kind of carrying the same idea of the Golf, for example, to be able to interoperate, I guess might be a good term for it, from the Earth stations. So as far as the idea of training on the ISS, that's a pretty cool idea. Although it is a trick to get things to the ISS, there's a whole lot of amazing qualification you have to go through. I don't know if you've seen any articles on it, but building something for that is a whole different league, because it's going into the human spaceflight environment. It's got to be amazingly, I guess you'd say, standardized and easy to operate, labeled, no accidental switch bumps or anything like we all do on our own radios, right? Because the astronauts wouldn't be so good at getting back to where they started from, right? If they accidentally hit the memory button or whatever the heck. I'm not saying they're not smart people. I'm just saying that they're not ham radio operators necessarily, to the degree that we can sometimes get ourselves into. But that's a great idea. The idea of having the opportunity to train, I don't see it happening real quick. On the other hand, I don't see people getting out and having microwave stations real quick. It's something that's going to have to develop, and especially, I would say, to make it more useful with higher and higher orbit microwave satellites, so that you're not trying to do a 10-minute pass, on 10 gigahertz and chasing Doppler all day long, trying to find the stupid signal or something. So I'm going to keep that in mind. I like that, and bring that up next time I talk to him. Juan Carlos Varanes, welcome. And if I welcome people twice, like I said, I'm not a professional streamer, so which could be the next with MEO or HEO orbit. For what we're doing with AMSAT NA, if you will, for one thing, there are openings, the restrictions are less than they used to be as far as working with other countries. So that would be something that would be a big boost to be able to get to, say, HEO or a MEO sooner, is to be able to have that collaboration of people. Right now, we've had a great influx of engineers into AMSAT here, and that is good, because for a long time we were tied by just having a few volunteers, and therefore we couldn't do a bunch of different things. Now we have many more coming on board, and that has given us the opportunity to expand, for like the Fox Plus and the new ASCENT projects and such like that, which is absolutely great, while we continue working on golf. Excuse me. And golf is the current path to HEO. The idea of the golf program, real quickly, is to develop the systems and the expertise that we need in order to fly a HEO satellite. And golf was originally intended to go to sequentially higher orbits, if you will, because we need to get into testing radiation. We need to be getting into testing, gathering higher power and such like that in that harsher environment. And that would include stepping through some MEO stuff. So that was the plan. The plan got altered quite a bit by the new orbital debris regulations. I say newest because especially the need to force your deorbit within 5 years of the end of mission and stuff like that really complicates things over the 25-year. Because simply, one of the simplest ways is because when we build these things, the end of mission is when it burns up. That's what we're shooting for, right? We're not thinking like, oh, it's going to die in 5 years, although with the Foxes it did, but that was their first CubeSats too. And a lousy choice of batteries, I'll just say that, because I didn't choose them. So the working through that to get to other orbits like MEO. Now, if you get into MEO and you get into circular MEO, you're great. You're above 2,000. There aren't any cheap launches for us to get there. It does not look like CSLI, that any of the rockets that are going there, which I don't know specifically any from the U.S., they're not carrying CubeSats in particular. So you could probably get a ride there, and as part of NASA CSLI, for example, but it would take, you probably have to wait a little bit. The way that we could, they have new corporations are building like tugs or otherwise hosted payload type of operations where they'll take you up there and fly you around, even up to MEO. And you would, instead of building a satellite, we'd build a payload for that. And so that's something that we're watching, we're following, looking for the opportunities for that. We don't have right now a payload other than linear transponder module, for example, or PACSAT fairly soon that we could put up there. But then we don't have any officers to go there specifically yet either, nor do we know about the pricing. We have more money to spend right now, so to speak, but we do not, it might not have access to be able to buy a launch to that. I'm just saying that's a possibility. I don't see us getting a free ride there too soon. So the HEO opportunity, that's what we are targeting. And even if Golf doesn't get out of LEO for a couple of iterations at least, we can develop all sorts of stuff that we need to know for the HEO, because the trick with the HEO, if you will, is that it's going to cost, if we build our own, and you're going to have to buy some propulsion, for example, and the ADCS, we cannot build one of those yet at least. It's going to cost maybe $500,000 for the satellite, right? And because you got to have your flight spare, you got to do all the testing and such like that, and it's going to have commercial propulsion, which is one of the big ticket items. And ADCS is that smaller. Plus, you have to throw in some radiation hardened stuff, because on a HEO you're going through the Van Allen belts a bunch. So you're not going to be flying CubeSat with COTS, little CMOS parts on it and stuff like that. So that it's going to cost, say, $500,000 maybe for the launch, because NASA will fund something like that with their CSLI, which is essentially a $300,000 grant toward a launch, which is the MSRP for a 3U to LEO. So if you take that up to a GTO, then you're getting into the MSRP of about $900,000 for a 3U. And so you would pay the overage there. So just pick a round number. Say $500,000, it's probably going to be less, but call it that. You're at about $1 million or something maybe to put up a HEO. So we need to make sure that if we're going to build a HEO and put it there, that it's something that's going to last while it's up there. It's got to go good. It's got to be well done. Otherwise, you kind of wasted $1 million, and we know what happens when that happens. It kind of turns a lot of people off, right? But it's, for the people that building it, it's a big hit too. It's a kick in the teeth, that you work so hard on something and then dang, it didn't quite work. And that's a basic tenet of hand radio. You build something, you put it on your desk, it smokes, but you can take it back to the workshop and do it again. You can't do that with a satellite, right? So we're stuck with trying to get there with that. That's where the international cooperation could help a whole lot. But it's also something that can tie in with other things going on, like, for example, the ERIS stuff. The idea of having a relay satellites maybe up in HEO or somewhere in an orbit like that, because the signal from the moon, for example, is going to be very weak, and people aren't going to have a 1 meter dish in their backyard too much these days. So something at HEO height, for example, as a relay, perhaps couple 2-3 HEOs up there, and you've got sort of a constellation to help that coverage. There's a lot of things in my mind about that. Which could be next? I would say I don't know. I mean, if we put something, if we're building for HEO, then we've got something that should fly in MEO. Therefore, which opportunity would come next? Who knows? A MEO is something that's going to pop up. We're looking for going to HEO right now. So if a MEO came up, then we would go, oh yeah, okay, we'll do that. But we're still continuing toward HEO. So I would say that if a progress is right, if we've got the manpower, whether or not international, and we've got money, in other words, a grant like ARDC has given us a grant for the space frame, the 3U space frame and the deployable solar panels for golf, and therefore, so we've got some, help with that in building it, right? So some such like that to help with the cost of what it's going to take to get there. That would be great. I think we could get to HEO in. Boy, the time scale is so different when you're doing it with volunteers. With volunteers, you say, I'm going to do 4 or 5 hours a week, which is quite a bit, really. It takes a lot of time. I mean, look at golf. Now, golf does have setbacks, so it's not a very good comparison, I guess, because of the loss of the ADCS. And boy, I'm just going, aren't I? The loss of the ADCS, the loss of Bob Davis, our mechanical engineer, that just bumped us. It bumped us off a launch, and so it set us back a couple of years, really. So if you take those couple of years out, we're at rolling on to 6 years of work with this. No, 5 years. 5 years of work with golf. So if you wanted to take that up to HEO, I would say it's going to be between 5 and 10 years. Unless something good comes along, a good offer, good opportunity. Can't say. I can probably say that I'm not going to be doing this in 5 or 10 years, which also makes it harder. If I consider and make a commitment, say, all right, as long as I'm VPE, and pushing like I'm 68, so I'm thinking maybe I should quit when I'm 70 because that's getting old. In any case, if I could stick it out, yeah, heck, we're going to get there fast because I still got HEO antennas up in my attic right there, just waiting to do some of that. So that's the driving force right now. So I would say I would put my money on HEO right offhand, but on the other hand, like I said, if a MEO came along and it's like, hey, we got a ride there for you, heck yes, we're going to jump on that. Let's see, where did I leave off? No, it could be next. Very good. And Juan Carlos, I guess, saying hi. So, hello. Or did you check out? Sorry. I guess you checked out, didn't you? Okay. Let's see. Ham radio. Oh. Hoping for more digipeater payloads, KH6WI. Well, the AMSAT that's being worked on in ASCENT right now, that's Bill Reed, NX5R, and a gang of guys from around the Dallas area. That is something that is at the working prototype stage right now, and there's discussion about carrying it into a flight model type of stage. The AMSAT itself, 4-channel up, 1-channel down, digipeater, digital store and forward system, a PACSAT as in the old PACSATs, is an opportunity to fly with some partners. Like we will give away an LTM to people who want to fly an amateur radio, cheaper than buying one. And the PACSAT will fly very likely on Fox Plus B, the second flight of Fox Plus. And we have some university partners that are possibly interested in flying it in the future. But we're talking in the future for 2 reasons. One, a flight-ready board would not be available until early mid-next year, 2025. And 2, nobody has said that they have a mission, come along and say, we have a mission ready that we want to fly something on it yet. So I don't know when that might come about. What'll be first, chicken and egg? Possibly Fox Plus B will be what is the first flight. So PACSAT going to LEO, that's coming up. Give it a year maybe or so, and could have something up there. The green cube up there in MEO, yeah, that's a hot setup, isn't it? That's absolutely great. Hopefully we could have a little easier access with the 4-channel up, for example, because the green cube is crowded, right? I mean, heck, half the world, well, not really, but a lot of the world can see it at once, and so that's a lot of signals up to one funnel, so to speak. So there are a lot of choices, opportunities I mean, PACSAT might make it to ISS, not in the iteration that's going to be produced by our guys. It would have to be taken and massaged, but it's an open source thing too. So somebody could take it and polish it into the kind of version that is needed for ISS, for example. And hello, Gene. Hey, Gene. What's going on in Texas? How come you're not out there for field day? Too hot? That's part of the reason. You know, I figure that if you're, up in age, so to speak, that you've done so many field days that it doesn't, I used to just be kind of rabid about it, I guess you'd say. Especially, of course, there was two opportunities. One of the guys in our club in Tri-County up in Hazel, Texas, had the Bushcraft and like I don't know if it was KLM or whatever, but the full long Heo type Yagis on a tripod, and so he would bring that to field day. Well, shoot, I mean, right there, it's like shooting fish in a barrel working satellites, right? That one, without that, it makes it a lot harder, and of course, then the rise and fall of the number of satellites makes it tricky. So it is not so much of an incentive, and especially our club here, it's pretty much a one-day thing, Saturday, and then when it gets dark, everybody starts going home, and so I wound up sitting it out for this year again. But it's just hotter than a pistol. It doesn't matter what year. You could probably have it in January to be the hottest January on record, right? Pedro, LU7ABF, thanks for the answers. And low-raw amateur bands is a reality on some sats, and interesting to add it to future satellites. AMSAT NA thinking about including any low-raw. No, not specifically. No. Let's see, was it University of Washington when we were doing the Husky Sat project with them? I was talking with the kids. What is a kid? If you're having fun with amateur radio, but the students that were working on that project about what else, because they got their ham licenses and stuff, if there's any other interests, and they did mention low-raw. They never got back to me on that though, which is not atypical, because when especially you're doing something for your senior project or whatever, and you're going to write your paper, you're going to get your degree, and then you're going to go out and get a job, and you're going to not have so much time for ham radio, right? So that's something that's been discussed, but it's nothing that anybody's brought forth. And basically the way it works with the satellites that we're building is somebody has to be interested in building whatever it is. So, for low-raw to be and something that we do, we're going to have people that are going to be willing, interested in building it. Right now, they're interested in building the stuff's going into golf and Fox Plus, I'll just say that. But that does not include the low-raw. Not excluding it, that if it came along, we would, certainly take a look at it. It kind of depends on what mission. It might be good for probably LEO stuff like Fox Plus, so that could be. And then back to Matthew. Relaying from the moon, very interesting. Make sure the signals are observable. Yeah, right. They might be observable with an FMHT if you have an observable dish hooked up to it. Yeah, it's tricky. I mean, even for from the perspective of what ARIS does, and I don't want to be speaking for them, so this may not be 100%, right? But their tenet is that they are I think not maybe tertiary or quaternary, if that's what the fourth one is, but they're a backup system. Okay, amateur radio is always a great backup system. So that is part of the reason that they are on ISS, on the human spaceflight type stuff, which would include the Gateway satellite, I guess you'd call it, the Gateway station, space station up there in the cislunar orbit. In what there's talking about putting on, for example, that the Gateway, lots of concern about the signal back to Earth from that, just direct to even the stations that would be like relay stations, like kind of the way you do the telebridge with the ISS contacts on some of them. It's going to take some hardware to be able to get a good signal from that. That was one of the things that, going back to what ASCENT did for the Heimdallr project, which was a consortium of people working on a satellite under the NASA CubeQuest Challenge, CQC it was called. And this was an initiative they had back in 2015, I think. We started it right after we started ASCENT. We were going to build the communications and ranging package. And that, the 5 and dime and such was chosen with that in mind. But the signal strength back from the moon, even with that thing with, I think, 40 watts of output at 10 gigahertz, was going to be very, very tricky. So it wasn't going to be something that a lot of people were going to get on there and just start chatting. So that does present a problem there. It's the way, you know, path loss works with a satellite is one end or the other, or a cooperation of both ends, being the satellite and the Earth, has to produce signals strong enough that it can be heard at the other end, basically, right? And so the ways to do that, microwave is one of the ways, because you can get bigger, more gain, better gain antennas in a smaller space. But it's a thing to overcome, which is why the HEO is kind of just a thought toward putting a relay up there. I mean, ultimately, maybe you would want some geos up there or something. I don't know. That's something that would have to be, in my opinion, coming from ARIS as the idea for it, because we're not going to just go out and be able to put up a string of geo satellites. More likely to do HEO, because they provide other opportunities beyond just being the relay to the moon. So I'm getting a lot of people checking in here. Matthew's question, hello Terry, ZL2 Bravo Alpha Charlie from New Zealand. Boy, it's nice to see everybody on here. There's a lot of people. I guess picked a good time. What time is it over there? It's about like 7 in the morning or something, isn't it? Hey, wait a minute. I got my geochron up there. That right? No, it's more like really noon or something, huh? Cool. Anyway, welcome here. I'm glad to see you all here, because and tossing out ideas to talk about, because there's just a ton of stuff in engineering. Never get enough time to talk about it in any of the presentations we do. So it's fun to dig deep into it and throw out ideas or statements of what we're doing and pick up input like this. Things that I'm going to take with me, like the 5 and dime on ISS. That's kind of cool. Matthew adds, let's see, VHF relay downlink or something back to the moon. Probably from, well, I don't know. If you talk specifically to the lunar, to HEO, to ground, it's probably going to be microwave, because of the CubeSat limitation, essentially. There was VHF and UHF on the HEO satellites that were up before AO10, AO13, AO40, but they had a ton of real estate to be able to have that power amplifier and those antennas to be able to make it a reality to the ground. And you could do with a CubeSat, you could probably get FT8, FT4 or something like that on VHF, UHF, but that's kind of a slow way to have a QSO, if you will, that's coming all the way from the moon. This is me interjecting my opinion here, but I think it'd be funner to have a conversation with somebody that way. Therefore, because the HEO would be up there doing its microwave thing anyway as part of a HEO concept, then it's probably microwave down from that. And up as well, I would guess. And yeah, that we almost want to consider building some relay capability as a secondary mission for future SATs. Yeah, that's a thought that when we had a while. And Michael, hello to you too. I'll get back to your question here in just a moment. Final thought there for what Matthew said is that a few years back, I'm thinking it's when was it? Whenever we had the symposium over there in Huntsville, one of the things that came up through their amateur radio club was the possibility of flying something on these commercial lunar landers that are now starting to make their way up there. And so we took a deep dive into that to look at what we could do to put a payload on there. And we turned out that I declined it. At the time, we did have fewer resources, but the limitations of doing it, and Bob Davis even had talked to some of the commercial providers, or those that were vying for it, and you're tied to their power. Most of them, well, actually the two that we talked to, I guess, they're talking about you're going to use their radio system. So that kind of eliminates the ham radio bit from it. Now, if we did put a payload on it that we could have our own antenna and be ham radio, that's going to be, your real low power signal, FT4, FT8, FT. Actually, it's going to have to be one of the stronger ones than that. JT 61, is it? And so you're going to have a few stations on the ground that are going to be able to make that QSO, and you're going to have a lifetime of maximum 14 days or a lunar day, because when it goes into darkness, those things were, at least at that time, all intended to be that they're going to die in the dark. There's no way to charge the battery or to hold the charge for the nighttime and come back around again. So that is, and coupled with that, there were a lot of restrictions or added requirements, I should say, on cleanliness for the satellite. What's being produced would go beyond the facilities that we have because you have to keep it from polluting the moon with microorganisms or whatever. Every time we sneeze on a CubeSat or something, we'd be violating it, right? So the whole overall cost, return on investment for making those few QSOs for a week or whatever, just didn't make any sense. And so that ties back in to what you're saying here about the relay capability. Yeah, if we're going to have anything of our own on the moon, whether through ARIS or otherwise, or around the moon, in order to make it something that's a viable ham satellite, it's going to take a relay capability. Even with the Heimdallr, it was going to be given to AMSAT after the mission was completed while they were orbiting the moon. It would eventually crash into the moon, wouldn't be able to stop it, but we would have a lunar ham satellite for some period of weeks or something. It would just be extremely hard for people to work. You'd have to have a 1 meter dish and all. So some people would be able to do it, yeah, and we were pursuing it. We were gonna make it happen, but it didn't happen, so there you go. So Terry's at 1:03 p.m. That's cool. I like that. I like that stupid question I asked because I've got the Geochron up there, and it's the TV display kind of picked it up after seeing it at Dayton last year. I'll still call it Dayton, but it's Hamvention, Xenia Hamvention, right? And it's kind of interesting because we're going to go to Alaska on vacation here in about 2 weeks, maybe a little less. And so I was looking at them getting about 4 hours of dark and 20 hours of daylight. Of course, by July, it's going to get a little bit longer, but dang, that's just a weird concept, I mean, I stay up till 3 in the morning, 4 in the morning, sometimes even close to 5. But as long as I go to bed before the sun comes up, well, if you only got that 4 hour window of the sun's going to be up all the time, that messes with my brain. So it's good to hear you on here. One of the things that we had with New Zealand specifically, pretty sure it was New Zealand, it might have been Australia, but there was one of the missions, launch missions, an Alana launch mission, that had a payload from over there somewhere. This was several years ago. And I know that the meeting time that was perfectly convenient for everybody in the U.S. was like 5 in the morning there or something. So it was quite a difference in trying to get everybody together. And of course, then the people over there were the ones that were put out with it, because you're the ones out there and hey, everybody else is here, so you're going to have to get up at 4 in the morning to be here too. And let's see, where we go then. We have Michael. Hello, Michael. I'm glad you're here. I really am. And anybody else, and just throw this in real quick. Anybody else is here, ham or not, you want to join the discussion? This is like a social hour Q&A, and I don't have to quit at 9 o'clock. That's local time, so I can talk for as long as you can stand it. Michael says, I'm a high school teacher who's traded messages with me. Oh, well, yeah, that's why you're familiar. I was thinking, anyways, we're a past era school and now CSLI. Oh, well, that's cool. Selectee. So how can my students and I get more involved with AMSAT? Excuse me? Or that jaw oil. So go ahead and answer this. Specifically involved, I'm not quite sure if you have specific type of involvement. We do get inquiries from projects that are going to fly amateur radio, right? That about the licensing especially. So Drew Glassbrenner is our Vice President of Operations, and he is also IARU representative, International Amateur Radio Union, that does the frequency coordination for amateur satellites. And so that's one avenue of the AMSAT involvement. In that AMSAT involvement, we're typically you're going to, obviously you're going to want to have an amateur radio payload, and in that, for AMSAT really to be interested, it is a matter of fact of it being an amateur radio payload, as opposed to an experiment with maybe just a downlink of telemetry downlink. Pardon me, as a possible part 5, the experimental in at 437 megahertz, just a simple downlink. If you've got a two-way amateur radio, and we can even give you one, the linear transponder module, for example, right? So then just let me know exactly, an idea, and you could email me, VPE at AMSAT.US, AMSAT.US, VPE Vice President Engineering at AMSAT.US. And let me know what you're interested in. That's probably easier than trying to do it back and forth through a half duplex chat and voice, huh? So do that, and then, I can elaborate or put you in touch and stuff like that. How's that sound? If you think it sounds great, then send me an email. If you think it sounds stupid, then write something else down there, and I'll talk about it. I ain't afraid of having a stupid answer. If I do something wrong or say something wrong, just tell me, and I'll correct it. That's how you learn, right? So let's see. Matthew, I appreciate the thoughts. And me too. I like this. This is a lot of cool discussion here. Pedro, LU7ABF, Yusuf from AMSAT Argentina. I haven't talked to you yet here, have I? I hope. I'm glad that you're here too. This is really interesting, the international audience, if you will. I kind of didn't expect it to be that big, and I'm really glad that it is, just because, well, like I said, it's hard to communicate all of this stuff that we're doing, also to take in ideas or whatever else from other AMSAT, right? And so that's very cool. So AMSAT Argentina, use of lithium-ion batteries on Fox showed that the lifetime is limited, but they were not lithium-ion. Fox, let me finish that, I guess. We have LO19 still active after 34 years on nickel metal hydride. What you use in the future satellites, what will you use? So first of all, the Fox had NiCad, nickel cadmium, and the Fox was designed specifically with NiCad in mind, because at that time, and we're going back, excuse me, 15 years ago, 2009-ish, and who knows, maybe the idea came a little bit before that, but the lithium-ion, the lithium batteries hadn't really been proven. I mean, and there's a trick to that, is that a lot of the satellites, excuse me a second, a lot of the satellites that are done by universities or other educational things, they have a limited mission time, and then pre-new orbital debris regulations, they would just stay up there, and who knows if they're dead or not. If somebody had kept a record of how long the thing worked with their lithium-ion or nickel metal hydride, whatever batteries, then that would have been very useful for determining the choice of batteries. Nickel cadmium, the NiCad, at the time that the Fox was being put together, a long history with AMSAT satellites that NiCad, if they are treated nicely, 20% depth of discharge, I believe, is what the maximum was being said at the time, then they would last a very long time. Lots of charge-discharge cycles is the key in that case. So that's why they flew with the NiCad. Now, we ran into some problems with it. I guess you could say a couple, three. One is that the NiCad batteries that were selected at that time were actually out of production. And they were, I believe they were 1700 milliamp hours. So they were Sanyo, I can't remember the model number. Nonetheless, we were given a bunch of batteries, or we had procured a bunch of batteries, and this was before I was even in there as systems engineer. But those batteries were being intended to be matched into match sets and flown on the Foxes. So there was 6 cells for each Fox. What we wound up with, well, there was first of all nobody that could do the matching. So when it came down to time to get batteries, or get those batteries going, if you will, I just happened to run into Everett at Batteries America. Forgot what they were called at the time, but Batteries America now, I believe. And he was at Hamcom. I went to him and asked him about matching these batteries that we had. And he looked at them and said, those cells are no good. They've been sitting around so long, out of production so long, essentially, that without having been, attended to, they had lost a lot of their capacity. He said, I can source some 1450, I think, cells that have more capacity than those 1700s had left in them. Excuse me. And so he was able to pull together 5 sets of they were Sanyo at the time. 5 sets of those 6 cells, so 30 cells total, and match them up for the 5 Fox satellites that we were going to have. Those were also out of production. And what we wound up with, as we found out, and I did not know any of this ahead of time since I was new at doing this, was that they also wound up sitting around a while, even though they were good match sets, but either a little bit, a year maybe or something before they ever went into a satellite. And then when they were into a satellite, as much as 2.5 years on AO-109, I think it was, from the completion, the date we had to have it ready to hand over to be put on the rocket, to the date that it actually made it to space, because of the delay of the rocket or the primary payload. So they were kind of a lost cause from the start there. Their life was already shortened by the fact that it was like, gee whiz, 8 or 10, not 10, but something on the order of 6 to 8 years after they were out of production before they ever hit it, and they were never tended. So that's part of the reason that the lifetime went bad. First, they were actually a newer but still out of date production, and then the bigger one is that despite the 20% depth of discharge and treating them nicely in space, we hit them with everything we had, and that was just a happening, I guess, of the desire to have this FM repeater on all the time, and the experiments that we're running with it, which were also kind of pre-cut in the CSLIs for 2 of them that we were flying. They were going to be a fairly good draw, the experiments, which got the launch, so to speak, through the CSLI educational. So we wound up discharging them way more than we should have. And that's a fault partly of mine, because I didn't actually know that much about batteries, partly of just a team-wide type of thing, because nobody's, I guess, really picked up on the fact that we were throwing so much at them. We didn't really, actually, by then, the person that had worked on the battery power supply had retired from the team, if you will, so we didn't have anybody who was expert in that sense. And so it fell through the cracks anyway, and that's what shortened the life on them. The combination of them being old cells and being abused cells. So they were NICAD. They should have lasted a lot longer. They didn't. There you go. Now we're into golf. And back to your question, just to refresh myself, yeah, nickel metal hydride is what you used. But we've gone now to the, you know what's funny about the NICAD? So the NICAD is such, I guess, older, even at the time for Fox 1A, which was 2014, that we had to actually short out a cell, one of these cells, and we had an extra one that was of the same lot that all the rest of them were, so we could blow it up. And we put a dead short on it to prove that it would, it's got a little safety valve cap on it, that it would outgas through that thing instead of catching fire or exploding or whatever. So we're out on the back porch here, throwing a dead short on the battery, measuring the current and the temperature and all this stuff for video on it and stuff like that, just to prove to range safety that the thing was safe. I don't know how safe we were, thinking back to what we did, though. It was a hell of a deal. But anyway, so we had to prove that for the what we do in order to fly even the NICAD back then. Now we're into the nickel, well, let's say, I keep wanting to say the nickel metal hydride, the lithium battery era. And it's been around for quite some time. So there is all manner of knowledge base in the CubeSat launching community, if you will, with the safety for that. The safety and the technology is there that comes with the battery, so to speak, so that it is, even though it's probably the most dangerous battery ever flown, it is kind of the safest through that sense. And so we are going with the lithium ion with these, or the first Golf satellites at least. Who knows what will come down the road. But so they are going to fly, and expect, we have people now that have, worked with them all the time in the auto industry. So some real good expertise as to how to be nice to them as well in the whole design of the satellite, so that we're not, taxing them. We also be able to take them out of the line if they go bad, and to keep them from shorting out or something, and taking down the satellite has been a past type of thing. So thank you, Angel. I appreciate that. And it's a lot of fun. Been having a lot of fun. This is a wonderful way to be able to share stuff. I'll say that, the Beam platform. So back to, let's see, Pedro. Yeah, so on the future satellites, it's going to be all lithium. And, well, the future two that we have underway with the Golf, Fox Plus is actually flying ISIS space EPS and batteries, and those are lithium. So that's what we're going with for now, or will be going with. Excuse me a sec. By the way, if you're still there, Angel, locked in. Okay. So let's see, we got that, Michael. There you are again. Love to fit a secondary amateur radio payload. Great. Provided us with the LTM information. Okay, and yeah. Little big and hungry. Yeah, the hungry part, I guess maybe just because, that's what our forte is, so we're building the satellite around that hungry part to be able to communicate stuff. And I think that the LTM could be tuned down, to consume a little bit less power, use a little bit less power. The whole idea of the payload trade is that you're flying the amateur radio payload so hams can get on there and play. Hams are more likely to want to support your telemetry downlink, which is where you get the bonus of that. And so you get that download or downlink all around the world, basically. And that type of information doesn't have to be coming in just at your ground station. Plus, well, my throat allergies picked a bad time to kick up. The amateur radio experience for the students, I have found that in the cases of the 3 or 4 satellites that we worked with, the Foxes, that the students involved with that, a lot of them would get their license, and then that kind of opens some new doors and some new eyes, really, on some of what you can do with radio besides it just being your, telemetry link, for example, command and telemetry. So you want to talk some more about that? We can take it. I don't know if you might have talked to Burns Fisher about it too. Burns Fisher, Eric Skoog, they would be able to tell you if I think that the power can be adjusted so that the power output lower, therefore lower power hungriness, if you will, right? And because it love to share the stuff, that's what ham radio is. And it gives you a good opportunity as well to share some of that education. So let's see, then we're back to Pedro. LUSAT 1 in 1989 got 100 batteries. Selected 8 with X-ray and bench with W3GEOI, Jan King. Okay, very good. And that was in 1989, yep. Installed and still active after 34 years. That's good stuff. It's really, and I just realized what I just said too. It's really encouraging. It's good to know that good engineering, which we can do, and I mean we, all of AMSAT or ham satellite, the AMSAT worldwide stuff. The expertise that's shared, as Jan did, the information is alive and well, because that's where you have to make the referral. That's what we're doing with the engineering setup that we have now, that actually Tony Montero had initially kind of kicked into motion as we got a new batch, a new generation of engineers when they went into Fox. Was pardon me a sec. I don't know what got in there, but gee whiz. Is that we have everything archived on a SVN. And so it's the opportunity to be able for people to go and look back and to learn these things that were lost in the past. It was done, it was probably written down, it was probably in somebody's files in their house or something. But the next generations or iterations of engineers that come along can't look back to figure out how do you match the batteries or something like that. That's why the Fox, I think, they had trouble, even though Jan King was around as part of AMSAT at the time. For whatever reason, I don't know, it was not connected with anybody that could do the matching. And therefore, they actually wound up there in my workshop in the garage, because they got sent back to me, if you will, because, well, I don't need these in my house anymore, so there you go. But that's good stuff. That's good stuff. And you know what else, the part I was talking about that I said was kind of interesting is that you're still active after 34 years. And that's also impressive, because the things that were done that are still active, AO7, for example, and LO19, after 34 years, the idea of being able to be in the orbit for 34 years is something that is just been taken away now, essentially. Until we can get high enough to get out of the regime of the orbital debris. Fortunately, I guess it's all mostly below 2,000 kilometers, so if we can get the heck out of there, excuse me again, get the heck out of there, then we can be up there for quite a while. And that would be lovely to be active like that. So congratulations on that. That's some very good stuff. Very good stuff. Ben, this has been a lot of fun talk. And let's see, Angel dropped off, so goodbye, Angel. And thanks for coming by. Angel Munoz, I don't know if you guys could see, he was probably on the Beam platform, but he's the co-founder of the corporation that Beam has come. They invented it. How's that? And it's a really high speed and tight, secure platform for doing the streaming, and you can do the distributed. So that's why I'm beaming out, and it's going to Twitch and to YouTube, and it could go to more places at once, except those are the only two I have an account. So it gives you guys, if you will, an opportunity to tune in, depending on what your favorite of those two ways to tune in. And anyways, then, so let's see. Yeah, the battery thing is an interesting thing, and with the Golf, yeah, unfortunately, it's kind of Fox 1, AO85. So Fox 1, the first one launched, went with an NRO satellite, and it wound up in an orbit that, according to DAS, the debris assessment simulation or software, degree assessment software that NASA puts out that helps you determine, for among other things, orbit lifetime, 18-year orbit. And that was within the 25-year. And I remember that when we found out what that orbit was going to be, it was like, dang, I wish we had not done this necessarily with the first satellite, because it's probably the one that's not going to be as robust as the following ones. Unfortunately, they didn't get to be as robust as we wanted because they were in such demand. They were just boom, 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 boom. We had 5 satellites done in 5 years. And some of them sat around a while before they launched. That's why they're so spread out. But so we didn't get to incorporate any lessons learned into them to much of an extent at all. Nonetheless, it's ironic then that you turn around to Golf T, for example, that's going to try to prove this new technology, and it's going to be our first flight with the lithium batteries to see how well we treat them or how they hold up. Because power is a big part of the thing for going to the higher stuff. I mean, you've got more equipment, electronics that you can fit. Because everything is smaller, you can fit a lot more in there. Things are more power hungry because we're radio nuts, right? So far as SDR goes, you want to throw everything at it that you can, and that's a bit of an exaggeration, but you know what I mean. So you're really eating through a lot of power and trying to gather power on something as tiny as a CubeSat, if you will, with the solar array and stuff like that, pointing at the sun or being able to steer it in the case it's fixed with golf is very important to keep those batteries in good shape. Yet the orbit, because we're going to be about 550 kilometers highest probably, and we're in, if it does launch in 2026, first quarter-ish or whatever, but we're in the peak of the sunspot cycle. So the orbit prediction per DAS is not very encouraging. You know, you talk about the 5-year rule, so to speak, now that instead of the 25-year, well, it turns out that we'd be lucky if the orbit lasts 5 years, you know, much less trying to get down within 5 years after end of mission. So yeah, it's ironic that maybe the best battery set that we've flown in years is going to be not have its opportunity to show how good it really can be. But that's all part of the game. It's still the opportunity to get out of that situation. Although the sunspot cycle comes and goes, but I mean, in general, to be able to get higher, which is what we all want to do with these, is it's there. It's just trickier than it used to be, for sure. But then what we do with, even though despite the life, you still know what the batteries did, or what the performance of the SDR, the performance of the solar cells, EPS, all of these things that we're testing. You know what they're doing, even for that 3-year period or something, and therefore that's something that you can learn and carry forward and develop still for when that opportunity comes to go higher. We've increased our knowledge, our capability, and so we move on up with that. And with the strong ASCENT going at it, with the propulsion is intriguing. And the propulsion, the team that's just starting up, excuse me, to work on propulsion, an electric type of propulsion, probably, yeah. But I'm not going to say they're going to do what they have in mind, and it'll be the best. But they're just starting up, so we're kind of exploring it. The idea of having our own propulsion is very intriguing, and just as in anything else, you know, anything else we can build ourselves for the satellite, for one thing, it saves a lot of money, but for another thing, it's fun, and it creates something new because ASCENT is open source that others can use. Now, some of it might be limited by ITAR or EAR. Perhaps propulsion is something that comes under ITAR. I don't know. Have to find that out. So it may not be open to the entire world that easily. Nonetheless, developing it for ourselves is a great thing because it is very expensive right now, right? And we're even working with a new company to try and do some flights with that, it's the same thing that we'll have to do for our own, and that is to prove it solid before we put it on something that we're going to send out of LEO, basically, and be able to rely on it and to demonstrate to FCC, NASA, whoever, that, look, we can control this spacecraft, we can maneuver it so we don't run into somebody, and we can bring it back. I think that's the biggest thing they care about. We can get it back within 5 years after end of mission. So we have an opportunity to let these guys go at it and come up with some cool stuff, but we're going to have to meter it out or test it out a lot before we take it out of LEO. So I'm excited about the idea that we can have our own stuff and that we can be able to use that. It just doesn't happen so immediately. It's too bad. I mean, we can get it into LEO immediately and get it tested out. There's people doing it all the time. Not so successfully a lot of times, so it'll be interesting. HuskySat-1, which was the University of Washington satellite that flew the first LTM, linear transponder module, their big push, sorry about that. Puns are just coming out, aren't they? What a day. Their big push was to do, we don't know a lot of detail about it, but they flew an electric propulsion that they were developing. I know that it didn't work quite the way they thought it was gonna. It was a lot harder than they thought, I guess you'd say, and they did not get the good results out of it, or good results that they would like to. So I don't know what the reasons for that was specifically, but it is, harder than it looks, that type of stuff. But they were up there. The point is that they were up there at, I forget, but somewhere around 500. No, I take it back. They were about 400 kilometer above ISS type of thing. And they were allowed to tool around. Now, I think they had some NASA involvement, but we would too, to make sure you don't crash into ISS and things like that. But they were allowed to test that out. So that's what I'm looking forward to. And what we do is that we'll be able to put it on. And we've got a pretty good track record. We've got actually a very good record of being by the book, as NASA put it in one case, and true to the regulations and spirit of flying CubeSats. So I think that it will be to our advantage, the respect that we have with NASA, to be able to put new propulsion on something and say we'd like to demonstrate this, test it out, and they'll welcome that opportunity, because they have been very gracious to us to fly. We fly experiments for STEM, so we're carrying student STEM experiments, and we're spreading education and opportunity that way, the space education. And so we've been religiously by the book. Like, you take the example I gave for the batteries with AO109 sitting 2.5 years. It was completed in 2018 in July, which means that hands off, it's done. The only thing we do is charge the battery periodically, and it's ready to be taken to integration. Well, Virgin Orbit had their trials and tribulations with the Launcher 1, and so it wound up that by the time we even went to integration was, I think, October of 2020. And so that's 2 years plus, almost 2.5 years later. Well, 2 years, 2.25 anyway. And then the launch wasn't until January of 2021. So, sorry I coughed in your ear too. So that was, that's your 2.5 year mark. So it sat there for 2.5 years. And because we didn't have the instructions on how to tend the batteries and the design of the satellite, the battery component, the EPS, I don't know if it would have allowed conditioning in that sense, because the input to it was basically, what was it? It was a 5 volt. Yeah, it was a USB type of wall wart. So 5-volt couple amp wall wart into USB connector through one or two diodes, I forget, as a voltage drop basically, and also for a reverse current thing. So and that was it. You put it on there and you charge it up till it was at, I don't know, 3.8 volts. I forget. No, 4.2 or so, I think. And then you let it sit there a while again until you have to charge it again. So I wrote down all the dates that I did it on there. It was about every couple months or something like that. I wrote them on the outside, and it was quite a list. But that's the only tending they got. That's the only care that those batteries got. And I only found out later in talking to Batteries America again about sourcing possibly more NiCad, and they said that they don't make good NiCads anymore, basically, that would be worth. He said something to the effect that the stuff that is available today, I would not give that bleep to anybody to put on a satellite. So anyway, we transitioned over to the lithium. So again, much more care with that. I guess I've worn everybody out. There's no more thoughts. Anybody got any? I'm gonna take a good throat clearing. So if you got any questions or even a topic that you want to talk about, I've got a lot of things on the slides here. I'll just jump into something maybe and see if that kicks up some thoughts too. But give me just a minute to see if I can get this here froggy out. And there you go. Maybe 4 hours of this in one day is a little too much for my throat, huh? I was scrolling down here, and this here presentation that I have up in front of me right now is what I did for Hamvention. I wound up doing a video of it because all the flights from DFW were canceled. As a matter of fact, I sat there at DFW airport for most of the day, and the first flight was canceled due, I'm not exactly sure why, because the weather was okay when that time rolled around and there were other planes leaving. But first flight was canceled. I'm on a second flight. Second flight was canceled. I'm on a third flight. Third flight kept getting delayed. And I finally said, you know what, just take me off of that and give me my money back, because I'm not going to get there in time to do my own presentation. It wasn't worth the trip. So came home and did a video. But it's 20 minutes of stuff that, we've been sitting here talking for 2 hours about a lot of it. But I thought I'd flip through the slides a little bit. Whoopsie. And just see if there's anything else to talk about. Let's say we did golf and stuff. The ADCS. Here's the, I'm going over that in this session here. Let me just make it bigger here. So the Gantt chart, the timeline for Golf T. Readiness date is 12/01 of 2025, next year, about a year and a half from now. The readiness date is, again, it kind of goes back to what I was saying about AO109 and such. That's the date that we have to have the thing completed, hands off. It's been tested, environmental tested, met all the qualifications of the mission, because the mission's usually underway sometime after you complete CDR, which will be in March of 2025. Then NASA, they're always watching along with it, and you're giving them reports and such. So then they're going to come up and they're going to look for a launch, and they've been eyeing them, if you will, and they're going to say, hey, we've got this launch. Will you accept it, basically? Because you have the opportunity to accept it, and it's usually going to go where you want to go. But if it came up where you didn't want to, you could say no, although you might wait a while before you get another opportunity. So sometime by the mid of next year, I would say we're probably going to be manifested on a launch. That means that the readiness date, we've put it through environmental testing. We've got it, everything taken care of, all the paperwork, blah, blah, et cetera, and it is ready to be put on a rocket. So if we do have that mission going that starts middle of next year, then it's a lot of times they take about a year out, but if we get it going there, right after CDR, for example, in March or something, if they pick us up, then we could launch in the first quarter of 2026. And so I'm not putting out launch dates anymore, especially because we're not manifested. So, the thing is that it'll be ready to go on a rocket in December of 2025. This is allowing a lot of time. We had to play a lot of catch up. Shoot, I blocked my chat here. Just one second. There we go. And here's Terry Osborne. Is there some data on Fox Plus available to non-U.S. members? There should be. Give me a second to recall. Everybody who's got Fox Telem has the option, although I think it's a default yes, that the data that you pick up off the telemetry gets sent to the central scrutinizer, the AMSAT server farm. So all of the data from all of the Foxes and such that anybody ever picked up, assuming they had the relay button checked, is in those servers. And you can get the data out of the server using Fox Telem by setting it up to, there's a function in it that says, and I haven't used it for a while, a menu function that says, fetch the data from the server essentially. And you set a date range and it'll go to the server and say, all right, for this satellite, pull out all of it gets all of it. I don't think you can narrow it down to any particular telemetry, but then it's not extensive stuff. So, you get a chunk of data from pick a year or whatever range you put in there. And then you can start looking through the historical data of all of those parameters that are of interest to you, including experiments, including the satellite health. I think that the images that were done with the Virginia Tech camera are not part of that, but they are available online. And that answers the question then. So yes, you can get all the data from any of it. It's all open to anybody because it's amateur radio and it has to be. You can't encrypt it on the downlink anyway. So that's why everybody gets to capture it and see it with Fox Telem, and then that's why you can pull it out and essentially replay it with Fox Telem. So you get a hold of Fox Telem, and if you don't know, you know what, I just read that wrong and I apologize. Let me just back up. Fox Plus, it didn't even register. So I'm going to start again. Let me get this out of my face real quick because it is bright and my asteroids. I got asteroids in my eye, which is kind of like cool considering what I do for a living here, huh? So data on Fox Plus available. You're talking about information about the design and the such like that. There's nothing that's, well, I can't say nothing. I just can't give you this the best answer on that. Mike Moore is the systems engineer. That he's the principal of the program, and I know it's open source, but I don't know how much is actually in there as of yet. I'm not quite sure what stage they're at with that. He just basically picked it up fairly recently when Jonathan Brandenburg had to step back, and so what they have available and the GitHub address. I'm trying to think of what the GitHub is. I can look at it. Hey, Matthew, are you still on here? You know what the GitHub is for Fox Plus? Maybe Matthew can answer that if he's still with us. So you could go look in GitHub anyway and see what's there. I just don't know exactly how much is there yet or what's been done. So Fox Plus, yeah, I was going down the road about how to get, well, there you go. You get the bonus prize there and how to get historical data from Fox One if you want it. What doesn't matter, so the thing about with what we're taking to be open source is it doesn't matter if you're non-US. That's the whole idea. We're, always been constrained, not always, but for my tenure, if you will, we've been constrained by the ITAR and export rules and stuff like that about what we can share, and pretty much just because it's difficult, we don't have lawyers and everything working for us to intervene and check everything we do or say. A lot of times we just get cagey about it and we don't say that much. So with Fox Plus, with everything going on in ASCENT that is being open source, open access, yeah, that's there for anybody because that's the way it should be anyway. It's amateur radio stuff. And the open access type stuff basically satisfies the export rules in that there's nothing to hide about it. In other words, it was something that's just the world could see from the get-go. Therefore, it's not anything that is regulated because it's not an item. It's not a thing yet. It's just the plans. Matthews Harry says he's not certain which where that's. Okay, not sure where the Fox Plus Git is. It might be in our own Git server, and it being migrated. He suggests that maybe it's being uploaded or migrated to GitHub, the public, if you will. So it may not be out there in the public yet, but it will be. I believe all of it is intended to be there. The only thing that might limit that is if there are certain articles that simply the U.S. law won't allow to be posted for whatever reason. I mean, with the shift in the way that the ITAR, International Traffic in Arms regulations, have been focused, we're not completely out. There are still some things like if you have a greater than 10 watt power amplifier, RF power amplifier for 10 gigahertz, 10 watts or greater, I believe, then that it becomes an ITAR item. Don't know why, personally. I mean, maybe it's because you could use it for radar or missile homing or I don't know what. So that's something that we would have to, not publish details on. We don't have any of that right now, though. So anything that isn't specifically nailed down by one of those, we want to get as much of it or all of it out in the public if we can. So I would say specifically for Fox Plus, let me ask. Mike has been on vacation. He's back. And actually would have talked to him yesterday, except we canceled that meeting because I don't have my PC. So if you want to send me an email, Terry, VPE, Vice President Engineering, VPE at AMSAT.us, not org or anything, it's US, AMSAT.us. Just send me an email and remind me that you were interested in where the Fox Plus data might be available. And then I will check with Mike, and Mike probably just have him talk to you or get a hold of you about it, where it is, what the plans are, and such like that. That's always the best. I don't like being the middleman on anything, so I'll just take you to the person who can answer the question. And thank you, Matthew. Geez, it's getting close to 2 hours. Well, this has been good, but it's kind of winding down a bit, so I think, calling it at 2 hours will be good. I had a lot of fun doing these. It's been a little bit of a challenge trying to do it with a laptop, but nonetheless, feedback would be great. If you got any feedback about audio level or, I don't know, how do I look? But, just let me know. Toss it in the comments because they'll stick there after the show, if you will. And I'm always willing to listen and improve, or listen at least. Everybody takes things for what they will, but you don't know anything's wrong. You don't know what it is unless you get criticism, and criticism can be good. And if anybody wants to toss anything out, I'll bet we can top the 2 hours. I think I hit a bit of a lull here because last night was really tough because we had to take one of our cats to the animal hospital emergency room. He had a blockage, bladder blockage, and so it was very painful, and he couldn't go. Imagine that. Yeah, so that's got to be no fun. But anyway, he's still there, and so there's, that kind of drags you down. Mentally, physically, I guess, and it actually makes you tired in a sense. So I think I'm just kind of winding down on this. And I'm trying to think if there's something else that I would really like to just toss out there based on what we've been talking about, especially. Go back over to this is the symposium presentation just to see if there's anything in particular here that was worth mentioning. I think something that'd be interesting to put out there for a discussion is the radiation tolerant IHU. This is something that came from an ASCENT project that was underway during the Fox, while we were finishing up the Fox program. So golf in 2017, when golf was being solidified as this is what we're going to do next, the radiation tolerant IHU is something that was there, that being developed in ASCENT, that became a good project for where we want to go with this. The background on IHU, internal housekeeping unit, that's the computer of the satellite. I'm not quite sure where the term IHU comes from, but it's as old as AMSAT, so I just go with it. The IHU that flew on the Fox 1 satellites was designed to be essentially non-mission critical and kind of dumb. KISS. Keep it simple, stupid. For the first, especially the first satellite you're going to ever put up, and it's not the first satellite for AMSAT, but it was the first CubeSat. With the chips and such that are being used, knowing that it would go through South Atlantic anomaly, which is where the radiation belts, the Van Allen and such, actually dip down a little closer to Earth because of an anomaly. And that's around, basically kind of covers South America, Brazil, Argentina, I think, and then over east into the Atlantic. So passing through that zone where you're hitting the higher radiation, there was concern that the IHU is going to be resetting itself. It's going to be going, cuckoo from some radiation hits, particles and such, single event upsets and the like. So the design was that the IHU would just be trucking along with this useful but not required operating, and it kept its current state in MRAM, magnetic RAM, as well as the basic boot up and software or firmware, I guess. So when it went through the South Atlantic anomaly, and it did it many, many, many times, not every time. There was a big discussion about whether it would be every time, sometimes once a week, twice a week, whatever, in the beginning. And I remember that as systems engineer, because I was trying to allot the right amount of bits to be able to keep a count of the reset counter, which, if you're familiar with the Foxes, we didn't have a clock on them, but we had a counter that would count seconds since the computer started up, so the reset counter. So every time it would go through the South Atlantic anomaly, it would kick and it would reboot. We'd start reset, increment the reset number by 1, and then start counting up again. And so it did it numerous times. RTIHU, a COTS solution to being able to have an IHU that is more tolerant to that type of radiation in order to be able to handle more mission critical functions, was born of that idea. And as it says here, there's two TMS 570 LS09114 PGE that are interconnected, and it has its own radio system as well for command. I'm not sure if the next slide has a little bit closer look, but you can see the two chips in the lower left. And if I recall correctly, each of these chips has 2 dies on it. So it adds to the redundancy of it by the dies on the chips are 90 degrees offset from each other. So theoretically, a particle hit that goes and hits whatever of the die number 1 doesn't hit that same spot in die number 2. Therefore, you don't lose, you don't have an upset. And so this would be, I don't think you're going to get it up, although we'll find out, into Van Allen belt for very long, at least. But the idea is, especially for the LEO even, to be able to survive through the SAA, South Atlantic anomaly, upsets and not go through a reboot, and therefore we can run more mission critical stuff, and hopefully higher. 1,200 kilometers was an option that we were shooting for with the Golf T, and that would have been a really good place to prove it up there into the higher radiation. We did not get the chance. Wow, forgot what a swell job I did with the animations here. So there's a close up of the RTIHU version 1.1, which is actually the current version that we're working with on Golf. There will be a 1.2, which is being finalized now for a spin. And so the two chips, and then between the two of them, they are working as active and standby. Sorry, bug. And they're communicating, and so that they're checking the health, and if something happens, it'll fail over. Well, I guess that was it for that. So the RTIHU in flying on Golf T, dang. I think I'm being bugged. We have the LTM, but the LTM is born of the transponder module, the command module, receiver, and the IHU from the Fox 1 satellites. So the legacy IHU, LIHU, the L stands for legacy, is flying on Golf T. It's flying because it's a known. We know that we can start the satellite with it. We know that it can function on its own without that IHU. We still have a transponder that works, and it's the fallback to everything, because it got all this other newer technology, including the SDR as a radio. That I'm sorry, this bug is just begging to die, but I don't want to slap myself in the face to make that happen. Okay, so the RTIHU, or that legacy IHU, is there in case everything else fails. If the whole satellite folds, if we can't deploy the solar panels, of course it's not going to have a lot of power, but if the ADCS can't control it, if the SDR doesn't work at all, although it's just doing the 10 gigahertz basically, and if the RTIHU fails, well, we still have an amateur radio satellite with known parts, the IHU, command receiver, and the transponder. The bonus to it being there is that along with the RTIHU, if we're going through the South Atlantic anomaly and the IHU, the old legacy IHU, has a reset and the RTIHU doesn't, it's not necessarily proof positive, obviously, but the idea is that it will be an indication that the RTIHU is perhaps more robust. And then, of course, over the lifetime of the satellite, which is in an orbit very similar to the rest of the previous Foxes, so that helps too, the altitude that is, then that's going to give us some indication of the RTIHU being not just functional, flying by itself being there, but also that it is more robust for at least those single event upsets. The RTIHU will be able to take command of the entire satellite, and we plan to do that, to hand it over to it and let it control it so that we can see how it performs with that. And then if it does fail, the legacy IHU has the capability of taking back the control of the satellite, and vice versa. If the LIHU were to fail for some reason, the RTIHU will take over, assuming it's doing fine. And so we have that, and hopefully this is going to be something that is going to be able to provide us with a more robust IHU. Now there's an added bonus, which is really getting out there into the statistically insignificant stuff, as Bob Davis used to tell me what I would come up with ideas. But we're going to be flying the Virginia Tech, not Virginia Tech, I'm sorry, the Vanderbilt ISD. They've been flying, we've been partnered with them since the day one with Golf One, or Fox One. And they do low energy proton experiments, basically. We've flown them on 3 of the I tell you what, 3 of the Fox One missions. And what they're looking for is a count on how often they get a single event to reset some ramps. Basically, they're putting a pattern of ones and zeros into some various different types of random access memory, and they're just letting it sit in there and waiting to see when one flips. So they're getting an indication, a count. And they're also comparing over the generations different types of chips at what might be more robust. So they're working with the idea of COTS memory, for example, in these experiments, to verify or to look for improved COTS components that are better for space. With that, and flying a Vanderbilt experiment that is the same as one of the previous Fox experiments, then we have a rough comparison of how many events are they measuring versus how many events are we having with LIHU and or RTIHU, that it might be able to provide a little bit of correlation between the environment and the resets of the IHUs. So that's a good opportunity to Golf T will be to try the new RTIHU and have the backup and the comparison of the previous IHU. So there. Look back to the chat again real quick. Let's see. Okay, Pedro. A map gotten from LUSAT. We mapped the dangerous SAA. On LUSAT, we placed tantalum plates over and down under, I presume, processors. The satellite lasted healthy for many years. The Fox 1 satellites and the Golf satellites and probably Fox Plus, we did use tantalum shield and over select chips, as you have said here, top and bottom typically, and so that is something that we did with that as well, including the IHU. The tantalum is a good trade-off of weight and such versus the ability to ding any low-energy particles, at least, to help mitigate that. So that's something that we agree on that. And now we don't have a measure of the degradation of anything like the IHU on Fox 1 from any of the resets or hits in the South Atlantic anomaly. As a matter of fact, we can't verify certainly that it was the IHU that caused the reset. It is possible that if one of the other systems took a hit that caused a latch up, then we have the FPF resettable fuses that would have kicked in and rebooted the entire thing. So some of those restarts could certainly have been caused by one of the other systems, not the IHU itself. And we didn't have telemetry that would tell us that. Nonetheless, the count of what happened within SAA is kind of the big thing as far as what we were looking for in the effect on the satellite. Douglas Qualiana had, and I don't know if it's still active up there. I'd have to look to see if I even still have the website, but he put together using Google Maps or Google Earth online. He took the data of because it's an estimate based on when the reset was, but we would actually, or we still are, plotting out where the satellite was when it took a hit and did a reset. And Alan Biddle was heading that project up, even though he's retired. He was kind of doing that, re-retired, because he retired and then worked for AMSAT and then retired again, right? So he's been keeping up with that. And Douglas took all those lat long points and or basic location points based on the reset and put them together into a map. And you can see just the big heat map of South Atlantic anomaly getting the bulk of them, although they did come from all sorts of various places, some possibly auroral or related to that up in the pole areas, some just in the middle of nowhere. So, who knows what caused the reset there. But it is interesting stuff. And the tantalum plates, yeah, that's something that's of great interest. As a matter of fact, and when we did one of the orbital debris assessments for, I think it might have been Fox 1A, we had a piece of lead that was really for ballast. And so it was a lead sheet, not necessarily as big as the 4x4, but it was under the battery board. It was on the bottom side of the battery board, which is in the center of the satellite. And it was basically added for ballast to push us up as close to 1.3 kilograms, I think is what we could do with the 1U at the time, so that we would have a longer lifetime. Bob Davis had erroneously mapped that on the components list that you send into NASA, because NASA actually did that orbital debris report for you on the CSLI Alana flights. So they took it in, and he booked it as this big old chunk of tantalum. And so NASA came, they sent me an email or something and said, we're concerned about how this, piece of material on the battery board, is going to survive reentry. And I said, what do you like? And I was thinking to myself, what do you think of the little? Because I was thinking of the little chips, right? This piece of tantalum is going to survive reentry and hurt somebody, basically. And I was thinking, what do you think? It's going to come in edgewise and not burn up or something and land on somebody's head? Well, then I found out, it turns out that instead of lead, he had put tantalum. So we had this big old chunk of tantalum coming down, and yeah, that was the concern. So when we corrected that and assuaged their concern, it was kind of funny, but it was a good show of what goes on in making the satellite. There's a lot of stuff behind the scenes for sure, and a little oopsie like that can make a difference, life and death, really, in what survives the reentry. The orbital debris report you have to show, and this is where the debris assessment software, DOS, that NASA puts out comes in. You have to show that none of the bits of the satellite, and you're booking down everything from nuts to screws to fasteners and whatever the heck else, so that it can all be combined and run through there and determine that it's going to burn up or not. I believe the number is 16 joules. It can't have over 16 or 19 joules of energy if it makes it to the surface. And I guess that's like a knock on the head with a little rock or something, basically. But so that's a big part of the orbital debris assessment, is to prove that you're not going to hurt anybody or anything when that thing comes through. You want it to burn up in the atmosphere. So that's why, and big choice of the materials that goes into the satellite is important at the beginning in order to make sure they are going to be stuff that's going to burn up. Lots of fascinating stuff that makes the satellite go versus, it's not just like, well, let's just build an amateur radio and put it in there. You could do that. It's not going to last very long. But there's a lot more even to that to prove that it's going to be something that's safe and healthy. You don't want to be polluting anything either. Nuclear reactors or something like that. Literally, they question you on radiation, radioactives, pressure vessels. You can't have something that's pressurized. One of the things that went through that, and I believe I picked this up on one of the mission calls for one of our launches, the Alana mission calls that we had every week or bi-weekly, I forget. But one of the other teams got dinged for having a pressure vessel because their horn antenna actually had a vacuum between internally, a vacuum for insulation and thermal insulation. And that was considered a pressure vessel. It's not pressurized, but it is something that if it was breached would have an implosion, I guess, in this case. Implosion, explosion, doesn't matter. They don't want that there. So that was something that they had to get a waiver on in order to be able to fly it. And but that's kind of like a benign thing that who would ever think of it in a sense, right? Obviously they didn't, and I could see where probably a lot of people wouldn't. Is you've got this little horn antenna, you don't even realize that the fact that it has the vacuum for thermal insulation in it, it makes it a pressure vessel. So there's a lot of the safety that's around the CubeSats is amazing, and it's been fun to watch how that has developed over the 10 years I've done it. With the very first launch, it was Alana Flight 12. It was the 12th flight of CubeSats, and it was on the Department of Defense. I think it was U.S. Air Force rocket, basically. It was is it Delta or Atlas? Gosh, I got to look. Anyway, and it had an NRO payload on it, National Reconnaissance Office, I guess, or organization. Either way, spy stuff. And so they were very, 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 very picky about these little fledgling payloads that were being put together by kids in schools and amateur space satellite builders. And the caution to that was absolutely extremely difficult. The tolerances, in the first place, you do go through all the same qualifications that anything would that's going to space. You have to meet those qualifications, but they are adding extra caution to that because they've got this multi-million-dollar, I won't say it, yeah, spy satellite, right? Basically, even though I'm sure that doesn't admit it anywhere. And they don't want any one of these little things, firecrackers, setting off a spark or something and blowing up their dang primary payload. You can't fault them for that. But it made it very tough. It made it very rigorous. Over the 10 years, you could see how the program changed, Alana, and how also the launch vehicle, the launch providers had changed and adapted to realize, okay, the CubeSats are being made to be as safe as anything else that would fly with us. And so that was a plus for it being more accepted and more launch opportunities. And the other end, the way that they adjusted it for the CubeSat industry was especially with NASA, with the CSLI, was that their flow of deliverable documents, certifying all the different things that you have to for the launch, became more polished. And I think that CSLI, NASA's Alana program, having had 2 launches that we purchased through spaceflight, where it was a DIY on our part to provide all this information that was coming to us from somebody who was kind of new at doing the CubeSats as well. So it was not as easy a flow to get through that. But the Alana program has made it so that from start to finish of your launch mission, you are well aware of what's going on and what you have to do and when you have to do it. And NASA has made a very good program of that. So all of these little details that you run into, and they'll vary by the integration manager, whoever's going to be, who is contracted to actually put the stuff on into the dispensers that go on the rocket. They are the ones that run the show as far as the mission, launch mission, and meeting all these requirements. And so they're a little bit different, one to the next, but still, it's become a very good process to get through all these. Like I said, there's just a ton of stuff, and that's a little bit of a tired statement. There's a lot of stuff that you have to qualify for to be just like the main payload on that rocket, basically, that you've got to survive vibration, you've got to survive shock, you have to be clean, hence the thermal vacuum bake out and such. But it's been reduced down to be something that's actually quite comfortable. And if you're interested, NASA has a book, it's a PDF called CubeSat 101, kind of like a college course, CubeSat 101. You can Google it or search it otherwise and find it. And that is a really good manual for the CubeSat launch process. And so if you're thinking about doing a CubeSat, or whether or not it's amateur radio, that's something that I would highly suggest you go take a look at. Drew, our VP operations, provided some of the information regarding the amateur radio licensing that they incorporated in there. So it's all drawn from experience and also the experiencees, I guess, the people that were involved in it. And so it's a really good manual for that. I think that's a good place to end. My voice is really going. I will say this for anybody who's still alive. I'm going to want to do this again, not real soon, but I think it's a good way to share information that just doesn't happen, like I said, at any of the presentations or even any particular video I can make. I can talk a lot more about unscripted stuff just out of a question or a suggestion that somebody puts in the comment than I can, you know, if I try to script a video to talk about stuff, it's not going to work very well. So maybe in a few months, let's see, symposium comes in October. Symposium is going to be in Tampa, Florida in October, I think. I'm not sure that that's officially booked yet or whether they put the word out on it yet or not. It has to be officially booked before it is publicized, so that I may be wrong, but I think that's the place that we were trying to go. So let's see, that's in October. We're in July, August, about 3 months. So maybe I'll do something around the same time, kind of like I did for Hamvention. That was the whole point of this thought, was that I wasn't there to talk to anybody, answer any questions, so I'll do an online thing. And I think it's been very successful. As a matter of fact, thank you, Ken. Appreciate you being here. Everybody that's been here tonight's been the biggest night, so to speak. And I don't know how many people are actually there but don't say anything, and I don't, hopefully a bunch, or hopefully people will watch this. And if you learn anything from it, that's great. If it raises more questions, that's great too, because, you know, this is amateur radio. Even if you're not a ham here, amateur radio is just a hobby. It gets into a lot of aspects of radio that are very scientific or what have you. And so that's why this is what we do. But the thing is that it's being a hobby, it's all about sharing what you do. Just like, I don't know, tying flyers, fly fishing and stuff like that. So that's where this becomes, you know, the opportunity to talk about what you're doing is great. And it's because this stuff gets kind of mystical, because we go, you know, other than when I sign off here, we're going to go off and do stuff for months to build a satellite, but you'll never really know what's going on, because for one thing, it's too massive to describe. You know, if you had a live video every day, it would get boring as heck, but you could see all the stuff that's going on. So, you know, it's fun to get on here and cover it. I'll quit. Thank you to everyone who's been here. And if you enjoyed it, spread the word and let us know, feedback to AMSAT or something that you want to do it again, and I wouldn't mind doing it again at all. Hours, if you're not from the U.S. or not in the U.S., let me know about what kind of hours work, because what I did for these was generally picked what I thought would be evening across the Atlantic there, and then evening again. So I was doing it at 2 p.m. our time and 7 p.m. our time for the U.S. And but going to the other side there, I mean, I guess it's noon. That's a weekend anyway. Over there in New Zealand, 1 p.m. when we started. So I guess that works out okay. But, you know, let us know. And you can write to the AMSAT. Oh, I don't remember the email address. The AMSAT, it's on the BBS. I mean, not the BBS, but the web. Just the contact AMSAT email address. help@amsat.org or something like that. Check it out. Send your suggestions there, because that's the place where they're going to get aggregated by Frank Karnauskas, and he's a very good person at handling our publicity, if you will. So then that can get feedback to me without me, nothing personal, but getting my email box stuffed with a bunch of thank yous or suggestions, or maybe not some thank yous, you know, because I like to keep that clear for just doing the satellite work. Because I tell you what, these guys on the team, they'll email me to death anyway. So 7-3, I'm going to put on a different slide and just say, I appreciate everybody being here. I appreciate the questions, and I appreciate the appreciation for what I'm doing. So y'all have a good night, good morning, good afternoon, wherever you are, and we'll talk again. Thank you.